Hello everyone, I welcome you all to this lecture series of alcohols, phenols and ethers, and this is lecture number 2. In the previous lecture we have discussed up to preparation of phenols and preparation of ethers and various physical properties and chemical properties we have just started. We have done with their reaction with metals and reaction with NaOH. So let's begin here with acidity of alcohols. So Uh, acidity, the basic rules will be applicable like acidity is directly proportional to minus I, inversely proportional to plus I. So more directly proportional to stability of conjugate base. More stable the conjugate base is, more stable acid is. For example, what is conjugate base? For example, HA is an acid. It will give rise to A negative plus H positive. So whatever is formed after loss of an proton, that is conjugate base. So let us take an example. For example, are various alcohols like CH3OH, C2H5OH, and C3H7OH. Okay, so among these alcohols, the maximum acidic will be methanol, then ethanol, then propanol. Why? Because plus I is maximum in case of propanol, and hence that will be the least acidic. And the primary alcohols are always more acidic than secondary alcohols, and secondary will be more acidic than tertiary alcohols. So what will happen here is, for example, like it's R2CHO negative. So it's already a negative charge. If we will apply electron releasing groups to it, plus I means electron releasing. So they will increase the electron density on oxygen. Hence, basically, if we can understand this thing in two ways, it will stabilize the negative charge and it will also result in decrease in polarity of OH bond, hence because of which acidic character will decrease. Okay, so basically more the alkyl groups are, less the compound acidic will be. One more fact we can mention here, that is MEOH, methyl alcohol, is more acidic than H2O. Methyl alcohol is more acidic than H2O. Next is acidity of phenols. So why is phenol acidic? Because it gives phenoxide ion. Phenols are generally more acidic than alkyl alcohols. Why? Because phenoxide ion is resonance stabilized, while in case of alkoxide ion, it is instead destabilized because of the plus I effect of R group. So because resonance is because the phenoxide ion is resonance stabilized, hence phenols will be more acidic than alcohols. So for example, let us take some phenol derivatives. Here I am taking orthonitrophenol, metanitrophenol, and paranitrophenol with phenol. So what we observe here is in case of phenol there is no effect, and in case of orthonitrophenol there is a minus I effect, there is a minus M effect, and there is a hydrogen bonding also present here, which is intramolecular. That's within the single molecule only, here like this. And in case of metanitrophenol, it's only minus I. The mesomeric effect is not applicable at meta position as we know, because NO2 will offer positive charge on negative charge only at ortho and para positions. So it will be withdrawing electrons basically only from ortho and para position. It will not be withdrawing electrons from meta position. Next to this, here minus I and minus M both are applicable. So if hydrogen bonding had not been present, if we have not considered the hydrogen bonding in case of orthonitrophenol, then there would be been a different order. Like para would have come earlier, and then ortho would came at the first. Okay, ortho nitrophenol would have been the maximum acidic if we have not considered intramolecular hydrogen bonding. But since this hydrogen bonding is there, so it just uh, makes it less acidic than paranitrophenol. Hence the paranitrophenol is most acidic. Then what comes is the orthonitrophenol, then metanitrophenol, and then comes the phenol. Okay, so that's it. Next is phenol, orthocresol, toluene with OH group or phenol with CH3 group. This is known as cresol. This is metacresol, and this is paracresol. So orthometa and paracresol along with phenol. Let us have a look at their order. Here there is a plus I and hyperconjugation. Here there is a plus I but no hyperconjugation. Hyperconjugation is also applicable only at ortho and para positions. And here there is a plus I as well as hyperconjugation. So what is most acidic here is definitely phenol. Next to this, what comes is metacresol, and next to this is paracresol, and then orthocresol. Why orthocresol is least acidic? Because it is having maximum plus I, and also hyperconjugation is present. So hyperconjugation is also something will be considered here. So the order here will be phenol, then metacresol, then paracresol, then orthocresol. Next to this is phenol, metamethoxyphenol. If methoxy group is attached at ortho, meta and para positions, so what will be the order? Now, in this case, there is a minus I and plus M. There is a minus I only. There is a minus I and plus M. So definitely we can predict meta will be maximum acidic because it is having a minus I effect and there is no effect. So meta will be maximum acidic, meta hydroxyanisole. And then what comes is either phenol. Next to this is plus M, because plus M will be the dominating factor. That's why we have took phenol prior to ortho hydroxyanisole and ortho parahydroxyanisole. So next to this is ortho hydroxyanisole. Next to this is para. Why para is at the end? Because of minus I. Minus I will be lesser. Okay, in case of ortho, more minus I. But there is a plus M, that's why they both are after the phenol. Okay. So considering all these effects, we can write this order. Next to this is phenol, orthobromophenol, metabromophenols, and then parabromophenols. Let's have a order for these phenol derivatives. So in this case, there is a minus I, there is a minus I, there is a minus. Plus M will be there, but that will be less dominating. So simply the order will be ortho, meta, and para, and then phenol. We must remember, in case of halogens, the orientation is something which is decided with the help of uh, the orientation is something which is decided by resonance effect or mesomeric effect. But here the reactivity is decided by inductive effect because that's more dominating in case of halogens being highly electronegative because they're highly electronegative. So in their case, the inductive is dominating over mesomeric, but in earlier case it was like in methoxy, the mesomeric is dominating, but in only this is the case where inductive is dominating. Next to this, what comes is uh, we can take as many as orders we want. OH, CH3, OH. So, what will be the most acidic will be this, then this, then this, then this. Okay. So, plus I is maximum here, hyperconjugation is maximum here, then plus I, then this. So that's how we decide acidity, considering the basic rules of acidity, like it's directly proportional to minus I, it's inversely proportional to plus I, it's directly proportional to minus M, it's inversely proportional to plus I. Most important is the stability of conjugate base. More stable is the conjugate base, more acidic an acid is. That's the most important thing we have to consider. Then the resonance factor and all will be considered according to stability of conjugate base only. So that's brief about the acidity of alcohols and phenols. So we will limit our discussion for acidity of alcohols and phenol up to here only. Next to there is a one more reaction which explains the acidity of alcohols and where from alcohols the hydrogen comes. So that's nothing, none other than esterification reaction. In the esterification reaction, H2O is formed as a byproduct along with the ester. And the important thing is the alcohol is something which is releasing its H plus ion to H2O. And OH is there comes from acid. The product formed is ester only, RC double bond OR. So here OH comes from acid and H comes from alcohol. This we have to remember. Here we have to take H plus. If H2SO4 here used as a source of H plus, it can do two things. It can act as a dehydrating agent as well as it can help to generate the uh, uh, that's cation. Okay, so there are two things which can happen because of H2SO4. So it will generate H plus as well as it will provide H plus to the reaction as well as it will act as a dehydrating agent. However, we can use any acid here like HCl also. If HCl is used in this reaction, then this reaction is known as Fischer-Spire reaction. And if H2SO4 is used here, it will provide H plus and it will also act as a dehydrating agent. Okay, so that's it. But this thing we have to remember that OH comes from acid and H comes from alcohol. Same reaction can be done with the help of acyl chloride, ROH can react with RC double bond or Cl. Okay, it can also give rise to ester. And we can take pyridine as a solvent here. Okay, so this was all about the reaction involving R O H bond cleavage. Now let us have a look at the reactions which involve R O H bond cleavage. So reaction of alcohol with HX, PCl3, PCl5, SOCl2, HCl in the presence of ZnCl2, as well as NaBr plus H2SO4. So all these were examples of the chemical reaction of alcohol. So ROH, that is reacted with HCl in the presence of ZnCl2. This forms RCl. This is also known as Grove's process. And the reagent is known as Lucas reagent. And this test is known as Lucas test. What happens in this test is this is a test for distinguishing in between primary, secondary, and tertiary alcohols. Next to this is uh, it can distinguish in between primary, secondary alcohol, tertiary alcohol with the help of which phenomenon that is known as turbidity. What is turbidity? It's the appearance of white silver mirror-like surface. White silver mirror-like surface. That's something known as turbidity. So this turbidity in case of primary alcohol appear in an hour. In case of secondary alcohol, this happens in 5 to 10 minutes. And in case of tertiary alcohol, it happens immediately or in a minute. Okay, so that's why it is a distinguished test for all them three. Primary, secondary, and tertiary alcohol. Next, we know very well the other reactions. We have studied in alkoalkanes and alvarins. That is reaction with PCl3. The byproduct formed here are more important because students generally forgot them for just they just don't remember it. Okay, they just mistake it in the exams. So the not remembering the byproduct is the common mistake. So we must not do it. Okay, so let's highlight it. Let's make this mistake less common. Next to this is ROH. When reacted with SOCl2, this forms RCl plus SO2 plus HCl. Okay, here also this reaction is also important because this is a named reaction, that's Darjan's process. But being a non-named reaction, this is not the reason for its importance. What is the reason for its importance is the gaseous products. As gaseous products are formed here in the reaction, they will escape out of the container and will allow reaction to complete nearly 100%. As per the Lee-Chatelier principle, reaction will keep moving in the forward direction and forward direction and forward direction until the reaction is 100% completed, until the 100% reactants are consumed. Because the product formed are gaseous, they will keep on escaping out of the container, keeping the equilibrium shifting in the forward direction according to Le Chatelier principle. So that's what the Dargel's process is. Next to this is, so these were the reactions, and more we can add here is NABR ROH plus NABR plus H2SO4. This give rise to RBR plus Na2SO4, okay, plus H2. Okay, so that's all about different chemical reactions giving rise to haloalkanes from alcohols. This we have studied also in the preparation of alcohols. Next to this, what we can do is dehydration with the alcohols, which will yield alkane. Dehydration can be of two types. It can be intramolecular or intermolecular. If it's a very high temperature, that's 170 degrees Celsius, the dehydration is intermolecular. Sorry, the dehydration is intramolecular. And if it's a temperature which is nearly 140 degrees Celsius, the dehydration is intermolecular, in between the two molecules of same kind, and in between a single molecule, that is intramolecular. So intramolecular dehydration leads to formation of alkene, and intermolecular dehydration is something which leads to formation of ether. And if it's a more lesser temperature, that's 110 degrees Celsius, that simply leads to addition of SO3H across the double bond, H and SO3H across the double bond, which leads to formation of sulfonic acid. Here we are discussing about preparation of alkene from alcohol. So we will do this. Okay, so alcohol undergoes dehydration reaction on heating with the protic acid. So suppose it's CH3, CH2, CH2, OH. It on reaction with concentrated H2SO4 at 170 degrees Celsius will yield CH3, CH double bond, CH2. That's something alkene. Okay. Next to this is, there are various other reagents we can use here. These are 85% H3PO4 at 440 Kelvin, and either we can use 20% H3PO4 at 358 Kelvin. So these are also the different reagents we can use here. So these are also the dehydrating agents. So let us have a look at its mechanism. The intermolecular dehydration mechanism we will study in ethers. Okay, preparation of ethers we will discuss it there only. So what is the step 1 here? It's the formation of protonated alcohol. Okay, so whatever it is, CH3, CH2, CH2OH we have taken, it will react with H plus. This will be a fast step and it will yield CH3, CH2, CH2, OH2 positive. Then step 2, that's formation of carbocation. We can put equilibrium sign here. Okay, this OH2 positive on more electronegative is highly unstable. So this will just leave it and will form a carbocation, that is CH3, CH2, CH2 positive, which will rearrange to form secondary carbocation CH3, CH positive, CH3, and further there is a formation of alkene in this step 3, that is by elimination of proton. So now removal of proton from either side carbon will form the same alkene, that's prop 1 in from the secondary carbocation. H plus will be released out from here, that CH2 CH CH3 prop 1 in will be formed. However, the proton must have been removed from the side, which can lead to the formation of a more stable alkene. Okay, so that is it. So that's all about the dehydration reaction. So let's end this lecture here only. Next to this is oxidation of alcohols and other things that we will study in next lecture. Thanks for watching the video. Have a good day. Bye bye.